Hello students, welcome to the EPG Pathshala. I am Dr. Lakshman Naik and working as a scientist at Dairy Chemistry Division, ICR, National Dairy Research Institute, Karnal, Haryana. Today we are going to discuss about beta glucan, its properties and health benefits under the paper Advances in Food Science and Technology. Dear students, beta glucans are polysaccharides of glucose monomers. These are linked by glycosidic bond. The beta glucans are a diverse group of molecule that can vary with the respect of their molecular mass, solubility, viscosity and three-dimensional configuration. So, beta glucans is a scientifically proven biologically defense modifier. Nutritionally potentiates the modulation of immunoresponse and has got many bioactivities and biofunctionalities. So let us discuss what are the beta glucans, its source, physicochemical properties, health benefits, and the main thing is its application in food system. With this background, the objectives are beta glucans and its classification, and the second objective is effect of processing on beta glucans and its properties. Let us discuss about beta glucans. Among many known and tested immunomodulators, a polysaccharide, that is beta glucan, occupies the prominent position. These glucans are extensively used as a food additives for the treatment of metabolic syndrome due to its numerous functional and bioactive properties. Glucans are glucose polymer, is classified according to their interchain linkage as being either alpha or beta linked. These are found in most of the cereals like barley, oats, and apart from these cereals, mushrooms also contains this beta glucans, and yeast also contains to the some extent, and it is also found in rye and wheat. Beta glucan has been gaining interest due to its multiple functional and bioactive properties. The fermentability of beta glucan and their ability to form a highly viscous solution in the human gut may constitute the basis for their health benefits. Applicability of beta glucan as a food ingredient is being widely considered with the dual purpose of increasing the fiber content of the food and enhancing the health properties. Let's discuss about the occurrence of beta glucan. Beta glucans are predominantly found in the internal alluron and suballuron cell walls. The content of beta glucan varies with the environmental conditions during the endosperm development, and it is regulated by enzymes beta glucan hydrolase, that's EC 3.2.1.73, and which facilitates the endosperm development and cell wall degradation during the germination. So, among the cereal, the highest content of beta glucan has been reported for barley, and it constitutes about 2 to 20 gram per 100 gram on dry weight basis. And after barley, the oat is the next richest source, and it constitutes 3 to 8 gram per 100 gram on dry weight basis. Other cereals also contains beta glucan, but in much lower. Other cereals like sorghum, rye, maize, wheat. The source of beta glucan include some type of some other sources apart from the cereals. Some other sources are like seaweed and various species of mushrooms such as reishi, shiitake. Some fractions rich in beta glucans are readily obtained from the cereals grains by dry milling followed by sieving and air clarification process, or by wet milling and then followed by sieving and solvent extraction. The approaches, these processing approaches result in two forms of beta glucan. That is, one is beta glucan concentrate and beta glucan isolates. The concentrate, beta glucan concentrates contains 8 to 30% of the beta glucan, whereas the beta glucan isolates constitutes 90% of the glucans. So these are the richest source of beta glucan products. Now let's discuss about the structure of beta glucan. Beta glucans are the group of polysaccharides consisting of D-glucose monomers. These are linked by beta glycosidic bond. The simplest glucan is the linear and unbranched beta 1,3 glucan. This is found among all prokaryotes and eukaryotes. Another simple structure type that occurs mostly in the non-lignified cell walls of the cereal grains, and it consists of linear beta 1,3,1,4 D glucans. Structural branched beta glucans are of different molecular weight are presented. So only the 1,3,1,6 and 1,3,1,4 linkage is represented. Coming to the next category, the branch structures of beta glucan, they consist of beta 1,3 or beta 1,4 glucan backbone with either 1,2 or 1,6 links of beta glucopyranosyl side branches. So these side branches make its branched glucans. They are major structural components of the cell wall of the yeast, fungi and some bacteria. The side branch of beta 1,3,1,2 glucan is the only present in the type 37 capsule of the bacterium Streptococcus pneumonia. Branched beta 1,4 and 1,6 glucans and 1,3 and 1,6 glucan are found in different groups of yeast, fungi and algae. In algae, beta glucans are present in stored polysaccharides or cell wall components. Apart from these linear branched, some cyclic beta glucans are also found to be occur. So these are 1,2 and 1,3, 1,6 beta glucans. These are isolated from various bacteria. These glucans are important for plant microbe interactions and they act as a signaling molecules during plant infection. This is the general structure of beta glucan. Let us discuss about classification of beta glucans. Most beta glucans are insoluble and the solubility of beta glucan is associated with the degree of polymerization. In short, it is referred as DP. When it is completely insoluble in water, its DP should be equal to 100. Beta glucan can be classified according to solubility properties like alkali insoluble, acetic acid insoluble, alkali soluble and highly branched beta glucans. A range of extraction and purification techniques are available for the extraction of beta glucan from cereals, mushroom and other sources, and they may include that hot water extraction, solvent extraction, enzyme extraction and alkali extraction. These approaches results in concentrates and isolates. These are the two type of beta glucan ingredients. The concentrate contains 8 to 30% of the beta glucan, whereas isolate contains up to 95% of the beta glucans. Beta glucans have shown to improve the health benefits, and that's why these are usually incorporated in many nutritional health products. So recently these are incorporated in fermented milk products. So these are shown to improve the mouthfeel and scoopability, and because of its water holding capacity and viscosity, they are very ideal candidate for the fermented milk products in fortification. Regulatory claims on beta glucans. The most documented nutritional benefit of beta glucan in food is its flattening of postprandial blood glucose and insulin level. The Food and Drug Administration (FDA) has acknowledged that nutritional claims that the use of dietary fibers reduce the glycemic and cholesterol response of the individual. Current recommendations suggest that an intake of 20 to 40 gram of dietary fiber per day per person. The FDA has certified a recommendation of 3 grams per day of beta glucan as having a nutritional effect. It has no known side effects even if it is consumed in extreme doses. It is also generally recognized as safe, means gross, it has got the gross status from the FDA. Owing to its importance, the FDA endorsed its use in food products and made it is obligatory for labeling requirement to acquire the specific health claims. Let us discuss about the properties of beta glucans. The physiological effect of beta glucans are mainly attributed to its physicochemical and structural properties which are interacting with the gastrointestinal tract, as reflected by its stability to generate viscous solutions at low concentration in the upper part of the gastrointestinal tract and to undergo fermentation in the colon. Many investigations have revealed that there is a direct correlation exists between dietary components with that of the treatment of metabolic syndrome. Hence, dietary components are regarded as the potential first line intervention in the health management practice. Dietary constituents are capable of controlling blood glucose, insulin, lipid, blood pressure, and with this food intake have been identified. There is a growing evidence that high intake of fruits, vegetables, legumes, and cereals are beneficial as they contain the soluble fractions of beta glucan. Many of their benefits have been attributed to their low glycemic properties and their dietary fiber content, and the focal point is beta glucan. So let's discuss about the properties. There are main three properties. Its viscosity and gelling properties, foaming capacity and foam stability, and water binding capacity. Let's discuss about the viscosity and gelling properties. Beta glucan is high molecular weight, linear polysaccharide and has a high volume occupancy in solution, that is high intrinsic viscosity. The high volume occupancy leads to polymer coil overlap and entanglement at low concentration, means even at 0.2 to 0.3% it exhibits the viscosity. So, above which the flow viscosity increases exponentially with the concentration and molecular weight to about fourth power. Some evidence shows that the primary factor responsible for the most of the exhibiting of the health benefits, means the low glycemic response in food, is the viscosity of beta glucan. The viscosity properties of beta glucan, as that of other polysaccharides, depends upon the concentration, its solubility, its molecular weight. In freshly prepared barley, beta glucan solutions, their attraction force between molecules are less strong, but after an induction period, some beta glucan solutions or dispersion may begin to adopt like a gel-like behavior. So, thus developing a high viscosity at low concentration. So, beta glucans also imparts the gelling behavior. It's also reported that chinning behavior of cereal beta glucan at low concentration, but at higher concentration they tend to form the gel. Their gelling properties are influenced by the molecular weight and molecular structure. So, usually higher molecular weight beta glucans gels do not show this shear thinning tendency. and the gel even after 200 hours of storage. On the other hand, short chain molecules with low molecular weight show higher mobility, and these short chains with low molecular weight beta glucan structure differ more readily and hence have a greater possibility for possibility of forming junction within the neighboring chains. Moving to the next property, foaming capacity and foaming stability. Foaming capacity and foaming stability properties are important when beta glucan is used as a functional ingredient and as a stabilizer in batters. Often it creates a high foaming capacity and stability is desired in the cakes and batters. A higher foaming capacity was observed when the sample was extracted with hot water extraction procedure, and this could be due to the relatively higher protein content that traps more air to develop more foam. A negative correlation is seen between the foaming capacity and viscosity. This shows that viscosity imparted by beta glucan makes liquid to foam with difficulty. Moving to the next property, water binding capacity. Water binding capacity of a fiber measures the amount of water retained by a fiber after subject to stress. These hydration property of beta glucan are important in many food applications and have an impact on shelf life of food products. Beta glucan extracted by hot water treatment exhibit highest values of water binding capacity, then followed by the alkali and then acid extracted beta glucan. The high value of water binding capacity of beta glucan suggested that this material could be used successfully as a functional ingredient to avoid synersis problem in various food products such as jam, jellies, curd, cheese. Synersis is the separation of water molecules. When it forms a high water binding, so free water is trapped and there will be no synersis, means separation of water. Health benefits of beta glucan. Beta glucan is the most powerful immunostimulant known. Beta glucan is used as a food additives for the treatment of metabolic syndrome and many diseases modifying agent. It is also used as a disease modifying agent as a natural source. Since beta glucans tend not to be degraded by human enzymes, they have the natural nutritional fiber property. So these are not easily degraded or digested by the small intestine. So it has the high water binding capacity and because of this nutritional fiber property. And then coming to the fermentability of beta glucan and their ability to form high viscous solutions in the human gut may constitute the basis of health benefits. So it is not easily fermented and the high viscous property, these two parameters are the main health benefit contributing parameters. So there are many health benefits are listed. It reduces the onset of colorectal cancer, increase the stool bulk and provide the assistant against constipation, reduces the glycemic index, flattens the postprandial blood glucose level, prevents the insulin resistance, lowers the blood lipid, especially the serum total and low density lipoprotein cholesterol. There are two types of cholesterol, HDL and LDL. This low density lipoprotein is bad cholesterol. Prevention, it helps in the prevention of coronary heart disease. It also helps in the production of short chain fatty acids. It prevents in the hepatic damage. Beta glucan promotes the growth of beneficial gut microflora, and it is suggests that it is acts as a prebiotic effect. Means these are the food for this acts as a food for the probiotics, and it helps in the healing of and rejuvenation of skin. So beta glucans are widely used as cosmetics.
So it has the rejuvenating for the skin effect, and it also stimulates the both hormonal and cellular immunity.
Let's discuss about effect of processing on characteristics of beta glucan. Processing may affect the molecular properties, that is chemical structure and degree of polymerization. It also affects the structural properties, mainly molecular interaction, and the next property is functional property. Those are the viscosity, water binding capacity, and solubility. All these in turn affect the sensory, physiological, and ultimately health benefit of beta glucan. Changes in these properties of beta glucan may arise from shearing damage due to the mechanical processing or by excessive heat treatment of food product. Unfavorable structural changes may also occur during commercial purification, such as the depolymerization of the linear structure, resulting in decreased molecular weight and reduced viscosity. Food and Drug Administration has given the gross status for the beta glucan, and the FDA recommendation is 3 gram per day to have a nutritional benefit. There is no unknown side effects are associated with the beta glucans. Because of this gross status and no unknown side effects, these are widely incorporated in different functional foods, ranging from milk products, fermented dairy products, nutritional health drinks like malted products, and other uh, different nutraceuticals.
Application of beta glucans in the manufacture of functional foods. So here we are going to emphasize mainly on the dairy products. Incorporation of beta glucans into low fat dairy products, this can make better mouthfeel, improves the scoopability, and improves the sensory properties which are resembling to the full fat products. Similarly, beta glucan incorporation into the low fat cheese curds has the beneficial effects on the gelation and rheological characteristics. Addition of beta glucan solution to milk modifies the curd formation, including the reducing the curd cutting time and increasing curd yield. So these effects appear to be related to the gelling capacity of beta glucan and their ability to form a highly structured elastic casein protein glucan matrix. So beta glucan interacts with the casein protein and forms a uh, matrix, and this is supposed to improve the many rheological properties in the when it is incorporated in dairy products. So main advantage is it prevents the synersis. So whey separation will not be there. It improves the mouth feel. Even low fat products also it has got the as similar property that of the high fat product when it is incorporated in the low fat products. In the case of curd, curd is also increased when it is incorporated in the cheese, and there was no there was a little reduction in the curd cutting time when incorporated in the cheese is reported. So these are the main benefits when it is used as a functional ingredient in dairy products. Let's discuss what are the challenges of beta glucan fortification. Means difficulties which are going to be encountered during the fortification of beta glucan in the functional foods. Development of beta glucan fortified foods remains highly challenging as consumers are not willing to accept greater health benefits on the expense of deteriorations in the sensory characteristics of the food products. Incorporating significant quantities of fiber into food products constitutes a technological challenge due to possible deleterious effects on textural quality. Addition of fibers may contribute to modification in the texture, sensory characteristics and shelf life of the food due to their water binding capacity, gelling, foaming ability, fat mimicking, anti-caking, anti-clumping, texturizing and thickening effect. Addition of beta-glucan to milk and dairy products was reported to be problematic and is mainly due to the problem of viscosity and which alters the sensory characteristics of the food, and the other problem is due to its typical slimy texture in the mouth. So these two parameters are the have to be addressed before incorporating into the food products. So this slimy texture in the mouthfeel and viscosity, these are the main difficulties when we are going to encounter when it is incorporated in the different food matrix. So not only in milk, in other products also we have to be carefully design our process. Let us discuss some of the uses of beta glucans. So beta glucans are scientifically proven as a biological defense modifier. These are nutritionally potentiate and modulates the immunoresponse. These are used as a temporary wound dressing materials. So these are some scientific evidence which are reported in the journals, and these are intended for management of partial thickness burns and used at the donor site and to allow the wound healing, and it is as a used as a collagen matrix, and it's also used with many other beauty skin glowing property in the beauty parlor materials.
Let us conclude the topic. From our discussion, it is clear that beta glucan is an important food component in the modulation of metabolic dysregulation, which are associated with the metabolic syndromes. However, dose, its form, its origin, molecular weight, and the carrier of food of beta glucan shape its effect. The physiological effect of beta glucan are mainly attributed to its physicochemical and structural characteristics. These are interacting with the gastrointestinal tract, as reflected by its ability to generate viscous solution at low concentration in the upper part of gastrointestinal tract and to undergo fermentation in the colon. Although physiological effect of ingested beta glucan is similar to that of other soluble fibers, its availability and ease of handling, which it is to be the increasingly incorporated into the foods with the purpose of increasing daily fiber consumption. It reduces the onset of colon cancer, increases the stool bulk, and provides the assistance against constipation. It also reduces the glycemic index and flattens the postprandial blood glucose level. It prevents the insulin resistance, lowers the blood lipid, especially serum total and the low density lipoprotein cholesterol, and it also helps in the prevention of coronary heart disease. It, it is related to production of short chain fatty acids and prevents in the hepatic damage, which and promotes the growth of beneficial microflora, as it is used as a probiotic effect, and it also helps in the rejuvenate of skin and stimulates both humoral and cellular immunity. These are the different benefits as we discussed and thank you for listening.